Main focus of the task in this training is as follows. First, before brazing the pipe for the repair, you should be able to reclaim the refrigerant that is charged into the machine. Second, before reclaiming the refrigerant, you should be able to conduct the evacuation procedure on the refrigerant recovery machine. Third, you should be able to understand how to connect the manifold gauge to the machine. Fourth, you should be able to understand how to connect and use the refrigerant recovery machine. Fifth, you should be able to understand the procedure for reclaiming the refrigerant. Sixth, the weight of the reclaimed refrigerant should be measured. Seventh, the leakage test should be conducted in all connecting parts before, during, and after the refrigerant recovery. Eighth, brazing should be mace according to the brazing standards. Ninth, when brazing the pipe, the brazed face should be even, and over 2/3 of the deposited metal should be penetrated into the sufficiently expanded connection part. 10th, the leakage test of the oxygen welder should be conducted before brazing. 11th, when igniting the flame, be careful not to cause any black smoke. 12th, you should be able to know how to control the intensity of the flame with a neutral flame. 13th, when the torch flame is strong, make sure the copper tube is not melted down. Please check the preparations and tools for this training. These are precautions. First, when reclaiming the refrigerant, make sure not to get low temperature burns and refrigerant loss. Second, make sure to always wear a personal safety gear such as safety goggles, long-sleeved clothes, and leather gloves. Third, when using a brazing torch, be careful not to get burned by the fire. Fourth, when brazing, make sure to conduct the oxygen welder leakage test thoroughly to check if there is any sign of gas leakage. Fifth, when brazing, make sure the replacement component and the surrounding components are not damaged by the heat or fire. Sixth, after using the brazing torch, make sure to close the gas valve and discharge the remaining gas inside the hose. Seventh, make sure not to get burnt by the heated copper tube after brazing it. Eighth, conduct the leakage test on the replacement component by pressurizing nitrogen to check if there is any sign of leakage. Ninth, make sure to install the replacement component in the right direction. Please check what you are going to perform on this task. Repairing the blocked pipe. Identify the pipe that is blocked and then replace it with a new pipe. Use a tube cutter to cut out the damaged part of the pipe. When cutting the copper tube, cut into the tube gradually by turning it several times, instead of cutting into it with a single strong trowel. Cut both sides of the dented part. Measure the length of the part where it is dented and cut a new copper tube for replacement. Even if the pipe is cut successfully, there might be a little distortion and some burrs around the cut edge. Remove all distorted part and some burrs around the cut edge by using a file and a reamer. Connect the yellow hose, which is the service hose of manifold gauge, to the nitrogen gas cylinder. The nitrogen gas cylinder is highly pressured, so make sure to install an appropriate regulator before using it. Connect each hose of the manifold gauge and conduct the leakage test on the connecting part to check if it has been connected according to regulations without any sign of gas leakage using detection solution such as soapy water. Use a pipe expander for expanding the pipe. Bring the expander to a halt. Insert the copper tube into the first groove. Slightly expand the front part of the tube. Then, insert the expander dice all the way into the tube. Operate the expander over 3 to 4 time trials to gradually expand the copper tube. Connect a new copper tube to where it is cut, and then remove the heat-insulating materials around the pipe. If you conduct brazing on site, a fire blanket should be installed to prevent the damage on the materials caused by torch flame. If you conduct brazing to connect the component that is vulnerable to the high temperature, use a wet cloth to protect the component and complete the brazing work as quickly as possible. Before brazing, wear welding leather gloves and open the valve of oxygen and acetylene cylinder to check the amount of remaining gas. Adjust the pressure control valve attached to the oxygen cylinder to adjust the working pressure to 5 bar. For acetylene, adjust the pressure control valve to adjust the working pressure to 0.5 bar. Open the torch valve to ignite and adjust the flame intensity to a neutral flame according to the pipe specification to be welded. Neutral flame is shown when the long wing-shaped white gets shorter and the center of flame is surrounded by blue-colored flame. When the pipe or the component to be brazed is heated up sufficiently to reach the melting point of the brazing rod, start brazing. Before brazing, check that there is no refrigerant gas left in the refrigeration equipment and ventilate the workshop. Even if nitrogen is vented into the pipe when brazing, be careful about the air tightness of the inlet side to prevent air from entering the refrigerator along with nitrogen. Make sure the deposited metal does not overflow into the pipe or any other components. Be sure the deposited metal is not applied too widely. After brazing is complete, close the high-pressure valve of oxygen and acetylene cylinder and release some remaining gas in the torch and gas hoses. Second, repairing the refrigerant overcharging. Before recovering the refrigerant, check whether the refrigerant recovery container is an empty bottle and measure the weight of the container. This is to measure the amount of refrigerant recovered. After completing the measurement, put down the recovery cylinder and put away the refrigerant scale. Before reclaiming the refrigerant from the refrigeration system, evacuate the refrigerant recovery machine, recovery cylinder, and the manifold gauge hose. The reason for evacuation work is to remove the non-condensing gas and moisture inside the recovery machine and the recovery container. Open all valves of manifold gauge connected to the refrigerant recovery machine and the recovery cylinder. Then, operate the vacuum pump which is connected to the cylinder. It is possible to evacuate each equipment separately, but evacuating all at once reduces time. After completing evacuation in accordance with the operating standards presented to the operator, close the valve of the recovery container connected to the vacuum pump. Then, stop and remove the vacuum pump. If the refrigerant recovery machine and the recovery cylinder are evacuated separately, connect the low-pressure hose of the manifold gauge to the evacuated refrigerant recovery container and the refrigerant recovery machine sequentially. When the connection is completed, the non-condensing gas inside the manifold gauge hose should be purged before full refrigerant recovery. Prepare refrigerant recovery by opening the high and low pressure valves of the refrigerator. If the refrigerant is overcharged, the discharging pressure increases abnormally, causing overcurrent relay or high-pressure controller to be operated and stop the refrigeration system. When the refrigerant is charged, make sure not to overcharge it to prevent this. If it has already been overcharged like this time, reclaim all refrigerant inside the refrigeration system and charge it with the adequate amount of new refrigerant. Since the refrigerant is defined as an environmental pollutant, make sure to be especially attentive when dealing with the refrigerant. Set the inlet switch to open and liquid according to the circumstances and retrieve refrigerant in the unit. The purge switch must be placed in the recover state, and the outlet valve must be set to open to recover the refrigerant in the unit. To recover the liquid refrigerant, first place the switch on the inlet side of the recovery device panel on the liquid and open the high-pressure valve of the manifold gauge to recover the liquid refrigerant. What is a push-pull method of refrigerant recovery? The recovery machine inhales gas refrigerant from the recovery container to make high-pressure discharge gas, and the high-pressure gas pushes the liquid refrigerant from the refrigerator to the recovery container. So, it quickly and safely recovers the liquid refrigerant from the large refrigerator. It also helps prevent the freezing of water-cooled refrigerators. When the liquid refrigerant is recovered, change the switch on the inlet of the recovery panel from liquid to open. The manifold gauge low-pressure side valve is also open to simultaneously recover the high and low-pressure refrigerant of the refrigerator. The reason why to reclaim the gas refrigerant after the liquid refrigerant is claimed is because it is the most effective and quickest way. The process for reclaiming the refrigerant only in vapor state takes a long time. During the process of recovering refrigerant, check whether there is any gas leakage into the atmosphere with a gas detector. With a gas detector, you can conveniently detect even the small amount of leakage. If it is placed on a leaking part, the light or the alarm is activated. Check for leakage without leaving out the connection of the refrigerator, manifold gauge, and the connection between the recovery machine and the recovery container. When recovering the liquid refrigerant, it is possible to work while looking at the sight gas. If the liquid refrigerant is no longer visible on the sight glass, the liquid refrigerant recovery is completed, so the remaining gas refrigerant is recovered afterward. After refrigerant recovery is completed, turn off the recovery machine and wait for a moment because the remaining refrigerant in the refrigerator can vaporize and cause the pressure to rise. Wait 2 to 3 minutes to see if the pressure in the refrigerator is rising. When the pressure in the refrigerator rises, operate the recovery machine again to recover all evaporated refrigerants. Repeat this task 2 to 3 times. When the blue low-pressure gauge of the manifold gauge indicates 0, close all manifold gauge valves and stop the operation of the recovery machine. Change the inlet switch on the recovery panel to purge. The low-pressure gauge attached to the recovery machine shows that the value increases from 0. Change the recovery switch of the recovery machine to purge. Purge operation is to send all refrigerant left in the recovery machine to the recovery container. It can be seen that the low gauge level of the recovery machine is falling quickly. After the purge is completed, close the valve of manifold gauge connecting the recovery machine and cylinder. Lock the outlet switch of the recovery machine into close mode and close the main valve of the recovery cylinder as well. Remove the hose of the manifold gauge connected to the refrigerator. Since the purge operation has been completed, even if the hose is removed, the amount of refrigerant released into the atmosphere will be very small. Using a refrigerant scale, measure the weight of the recovery cylinder which has just reclaimed the refrigerant. If subtracting the weight of the empty cylinder from the measured weight, the total amount of the reclaimed refrigerant can be obtained. Attach a sticker that shows the amount of the reclaimed refrigerant, refrigerant type, and the date. Cap the recovery cylinder and conduct the leakage test with a gas detector. Check again the key points of the task we've worked on in this training. In this training, we have learned the process 1 to repair the failure of air conditioning unit. Everybody, thank you for your hard works.